This is Unit 2, Lesson 1, Example 1B. List the dimensions of at least 3 pictures that are proportional to the original picture. Find at least one picture that has a dimension that is not a whole number. I'm going to use the equation tool, which is a division symbol here, just to show you how you can type in fractions for those of you that like to type more than write. The rule is that you will always use the y point over the x point, always. Now, to get to the divide, the fraction bar there, I just typed the slash, this under the question mark on your keyboard. But now I want to show that in words. So my y, and I can see here that my y point is the up and down, the y is the height. So that means that it will be my height over my width, because I can see over here that the width is the x. So whenever you set up a ratio like that, from a graph, you're always going to put the y point in the numerator and the x point in the denominator. Now our question is asking us to find at least 3 different dimensions that are also proportional to my original. So my original, the height was 3 and the width was 4. And they're asking me to find points that are proportional to that. And I just want to move these so they're closer. So if I look back to the example I showed you before, I know that I have 3 and 4, and I know that an equal ratio of 3 and 4, if it has a scale factor of 2, that will be 6 by 8. And I can show you here, if I increase the sides, notice that I have a picture that is 6 tall and that is 8 wide, and it is still proportional to the original picture. So I'm going to go ahead and draw that. And if you're good at the line tool, you can use the line tool also. So I see, here's my point. So that picture would be 6 by 8. So it's 6 tall and 8 wide. But now I need to find another dimension. So I could use a scale factor of 3 instead. And if I use a scale factor of 3, 3 times 3 is 9. 4 times 3 is 12. So I could also have the ratio of 9 over 12. And I can see in my picture, 12 is all the way at the end of the x. So this picture, I'm sorry, I wanted to do that color coded so you could tell better. So this picture will be 9 by 12. So the height is 9 inches, the width is 12 inches. But we wouldn't have to have a scale factor that is a whole number. So that's the next thing. But first I want to prove to you that 9 by 12 is proportional. But our question required that we have another size that is not whole number dimensions. So I'm going to use 4.5 because that's a decimal, not a whole number. 4.5 by 6. So notice that your ratios do not have to have whole numbers. So my next set of dimensions is 4.5 by 6. That means that the height is going to be 4.5 inches. So 4.5 inches. And the width is going to be 6 inches. But each of those shapes is proportional to the original picture. Each of the ratios is the same. And now a really cool thing about math. This is one, sometimes math is just cool. There's so many things that work out really neatly, and this is one. The unit rate for all the ratios will be the same. They're going to all be exactly the same, and I need to get rid of my picture here so you can see it. So it doesn't matter what I do. If my first unit rate, or it doesn't matter which one I use. So if my first unit rate is 3/4, my first ratio is 3/4, and I turn it into a unit rate, and I divide by 4, I will get 0.75. But if you try that for all 4 of them, you're going to see that it is the exact same thing, even with our ugly decimal question. If I have 4.5/6 and I want to find that unit rate, remember a unit rate has a denominator of 1, so I will divide by 6, and 4.5 divided by 6 is still 0.75. So all of our ratios, comparing the height to the width, will have the same unit rate of 0.75 inches of height for every 1 inch of width.